My name is Andrus Rachunas, AC Technical Services Manager here in Building Point, Australia. And with me here today will be joining Oscar Salvador, our API developer, and Jeremy Tozer, are probably the best concrete specialist in here as well. What we will be going through, if I can just change the slides, is we're going to focus mostly about the live quick demonstration of Tekla Structures and concrete tools, rebar editing, and a few drawings in there. What I'll go through is a very quick and brief introduction of concrete within Tekla Structures, what it is and what it can produce by itself. And then, as I mentioned, we can have, and we will have a Q&A session. So in the meantime, I think at the top of your, where you see the screen, meeting, you will see a Q&A section where you can put the questions in, and then we will be looking at them throughout the demonstration. So a very brief and quick introduction about concrete structures and Tekla Structures. I'm not going to go through how to do the basic stuff, how to model it and all of that, and what it actually does. This is just to mention what you can actually export and produce when you have a model. So Tekla Structures can export a BIM model in any stage of the project. There is the tender, estimation, planning, production, or construction stages. So it can go vary from LOD 100 to LOD 450 and 500. So millimeter precise, concrete covers, and all of that. Everything you model in Tekla Structures, and you create a drawing, and then if you change anything within the model, drawing changes accordingly. So you can have accurate and up-to-date drawings, your rebar schedules, such as export Excel reports, PDF reports, and so forth. Your bar bending files like BVBS, mesh welding files, and plenty of other reports and templates in there. Collaboration files, not forget about these. So all your collaborative efforts with surveyors, builders, you can export 3D, 2D, DWG files, layout points with coordinate systems based on Teklas or any provided surveyors systems that you can place in Tekla Structures, your IFCs, and so forth. Plenty of other files that you can export to third-party applications. And any other relevant data that you can later on merge in Trimble Connect as well. If it's a point cloud, a markup, a DWG, a IFC model from Architect, from MEP Solutions, you can turn on and off them in Trimble Connect and have it in one collaborative platform that is included with all your Tekla Structures licenses as well. We will have a separate webinar on Trimble Connect separately, which not too sure if it's going to be next month or in September, but stay tuned on LinkedIn and you will see a mentioning in there. So how to achieve that export? So for those who haven't used Tekla Structures for, let's say, precast, it's plain and simple. Model a concrete structure in 3D, which we'll have a brief showing after this. You place reinforcement via automated components, manual input, or using the advanced rebar sets, which we'll also cover. You create drawings automatically with your specified rules for dimensioning, part representation, and rebar markings. Select elements that you want to export for your IFC or reports, and then just click export. So fairly simple, easy process. We'll try to cover most of these in a short demonstration. A few highlights that I would kind of point out why Tekla Structures. So it would be because of the rebar sets. It's probably the most intelligent rebar placement tool out there. Recognizes faces and sets out even if it's a curved or bended item, you can actually still put a reinforcement that reacts to the cover that you specify. Direct modification system, so you can drag and drop insert points that you placed it in Tekla Structures. And much more. Automatic rebar numbering that you don't need to put in your numbers. It automatically does for you if it's a different rebar, it numbers it differently. Rebar shape catalog and management, so you can specify your own rebar shapes and have your rebar codes with you specific for your company needs. Modifiers and splitters. If you have, let's say, a mesh or a few rebars on a beam, you can specify where to split it, how much of the overlap needs to be, if it needs to be a cranked one or not. You can do that in there. Clash detection and quality control, both in Tekla Structures and Trimble Connect is also possible. bar bending schedules that I mentioned before, the BVBS files, reinforcement mesh tools. There are plenty of components within Tekla Structures. Concrete cover management, which is in all of the rebar tools and components within Tekla Structures. One of the main features is the 3D visualization, communication, and coordination that it's within the Trimble environment that is in Tekla Structures, Trimble Connect, and other Trimble products. And the last one is probably component library integration, which is in Tekla words is we call it the custom component. So if it's not there, you can build up your own tools. And if something's missing out of the in-the-box solutions as well, for you who don't know, there's Tekla Warehouse as well that you can download any available application that someone else created or even us created or even different regions of Tekla Structures created, and you can download and use those, or even use the third-party applicators who have their business solely on creating Tekla Structures components. And that's more or less what I had to, like a really quick introduction. Probably most of you know what Tekla Structures is, and after this, we now want to kind of focus on a very short, very simple model example on how you can manage these tools, some of the tools. And within, I'll pass it on to Jeremy, but then within this time frame, feel free to put in the Q&A questions, and then we'll go from there. All right, Jeremy.
Hey guys, how's it going? So we're just starting here with a basic set out. We've put a reference plan in here. I'm just going to go and grab some footings, some pads and starters, and we're just going to drop a pad in here. I'm going to drop it there, and then I'm going to move it. And then I'm going to copy this one here into where all my pads are going. So now we've got the pads in, we're just going to go and throw in some strip footing. I'm just using the factory standard ones that you can make them any size you like. Leave the curve one to last. Now, I do need to move this one out a little bit, I think. So if I grab that one and that one, that's not quite square, is it? No. I might do that one again so I get it nice and square. I'm just going to use a reference line from the center to there. So then when I go in with the pad, with the strip, no. That's central, isn't it? Straight. All right. Try that again. All right, now in order to get our curve in here, we're just going to basically select that there, and under the properties here, you can go and pick rounding, and we're going to make that 3 meters. So now we've got our radius, our curve, and our strip footing. What I'll do is I'm just going to select all of this and change I might just select it like this. and change the color of it just so it doesn't clash with the panels that we put in later. Right, now we'll go into the 3D view and we will throw some Rio in here. So in here under rebar, I'm going to use rebar sets because these things are great. Before I do that though, I'm going to go grab these pads and I'm going to set my cover. So you can either have global cover, we can have local cover. So we'll go local. We'll go 50, 75, 50, 50, because your foundation is obviously against the ground normally, so you want cover. And then I'll do the same with the strips. If you've got everything with the same cover, you can just set that globally, so everything automatically gets that cover. 75 bottom. And there we go. Now, if we use the crossing tool, we have a look at our properties and what we've got set. So I think for the pad foundations, we're going to go N16s, and we'll leave them red. So your crossing basically takes across any object that you've modeled, and it will put the rebar in. So I'll just turn the top bar off because I don't need the top bar in there. And then we're going to model the other ones the other way. And then all I'm going to do, escape out of that command, and I'm going to grab those bars and I'm going to copy them from the corner. There are other ways you can do this as well. There's, depending on your license, you can have access to the batch editor, which is a very powerful tool for this sort of thing. Right, so that's our bars in there. Now we'll throw some stirrups in here, also using the crossing tool. But we'll make these bars 10 strips and ties, and we'll make them green. Now we've got to check the distribution. At the moment it's at 200 centers, so we'll leave it at that, and we'll just put our stirrups in there. And now you'll see the stirrups here have gone a bit weird around the corner, but I'll show you how to sort that in a minute. Now with your stirrups, this used to be one of my bugbears when I was doing reinforcing, trying to get the stirrups right. They've fixed that with these rebar sets, so I can go in here. I need to turn my direct modification on, grab the bars, and then you get the options up here for your rebar sets, which you can then go to end detail, and in your properties, you'll see here, I can go 135-degree hooks, pick the corner that's open on your, and automatically puts your returns onto those bars. And we'll do the same there, end detail. And I should remember what you've used last time. You've just got to pick that corner, and it does both of them at the same time. In detail. And then what we'll do is we'll sort this radius out properly in detail on these ones. So with your direct modification on, for these ones here, you grab your handle and you drag it to one of your faces. Make sure it's either on the top or the bottom corner. In this case, I will put it on the top corner, and then we'll do the same with this one here. Put this handle here up on the top corner. Then you select your tools. If you look down on it, you'll see this little context menu here. This button here means follow edges, so you click on that one, and automatically the stirrups have all now followed the curve because that bar has followed that 3-meter radius around. So we can do the same here with the returns. So it remembers what we had and what side are we on the outside. There we go. And now we've got the returns on all our bars. So now we just need to put some longitudinals in there, and we're going to go longitudinals, And we're going to change the bars. We'll go 20 main. And you'll notice then when I select the bars, it gives you this library, and it's automatically got the bending radiuses. It's actually got all the information about the bars, how much lap it needs, absolutely everything, based on New Zealand or Australian standards, depending on what you're using. So we're going to go 20s here. We'll make them a different color. We'll make them yellow. And this one here, it selects the same, but see, it's only selected the bottom line. So I'm going to select the top line as well, and then hit my middle button to agree to that. And now we've got longitudinal bars, and they fit nicely inside the stirrups. We're going to do the same here. So just select the top as well, middle button. And now you'll see that it's conformed to the curve as well. So you've got your nice curved bars in there. And then obviously from an engineer's perspective, that doesn't bloody work because you've got to have some sort of a lap in there. So what we'll do is if we grab, might do the bottom ones first. If we grab those bottom bars there, we go in detail. Under here, we're going to put a 180-degree hook on the bottom because otherwise it's going to stick through. And then you can add an adjustment to it. So you can go end offset, and we can go 500. And then you just basically hover over it, and this is your modifier line. Put your modifier in, it automatically extends your bars 500 and puts a return on them. Now the top ones, we can do the same in detail, but we can make those 90 degrees. And there they are. Oh, look, we've missed some. I'll just put some longitudinals in here. There we go. So you could go around and do that with all your corners, depending on what your engineer requires. It's very, very flexible. So yeah, so that's your foundations. Now I'll do a. So we're doing a shared model here. I'm sitting in Christchurch, and Oscar is over in Brisbane. So I'm going to now write out. So then he gets the foundation, and Oscar's going to model some panels for us. You want to take the screen, Oscar? Oh, you'll have to write in first, won't you?
Yes, yeah, I'm just waiting for your write-up to come in.
Yeah, and in the meantime, then well, this transition comes in place, as Jeremy mentioned. Yeah, so Jeremy is back in New Zealand. Oscar is in Brisbane. I'm actually sitting in Sydney as well, and we're all working in the same model. So what Jeremy just did is he written out all the changes that he made, and momentarily, Oscar will, when he'll start sharing his screen, he will show. Yeah, here already. So there was a notification on the left top corner for Oscar that some changes were written out. So he just clicked on read in, and this is what basically came up to his model now. So I'll stop talking now, Oscar.
That's all good, mate. Yep, good afternoon, morning, and evening to everyone, depending on where you are now. Today, I will share my experience in modeling and detailing precast panel using Tekla Structures, which has been my job before joining Building Point Australian team. I saw some from Adventure here, probably knows me. This may not be much, but hopefully you can get something from this. So we have a model here shared by Jeremy to me with existing reference drawing, and you can see some foundation and strip footing already. And let us use the reference drawing in here to trace the precast panel. So I love doing the trace in 3D model or in 3D view because I can visualize the panel as they were created. And with the proper snap and rendering switching, we should be able to do this. And so I'm going to model the panel using two different approaches. First, I'm going to show you the wall layout tool, which is in this ribbon. And before I proceed, let me mention that it is ideal to pick the panel from left to right, as if you are looking at it in the drawing. I will show you why this is important as we move forward. Okay, so while I'm holding the Shift key, so I press the icon in here to show the wall layout properties. I want to do a 5.6 meter height wall with 175 thickness. So we will do a single layer for the meantime. I will apply and OK. So I will click in this corner here. Then in here. And as you can see, this intersection in here, what I will do is I will hold the control button and click in here. And I will snap back from where I started, and I will type in 10 millimeters. And then when I press enter, my panel will now lies on the 10 mil away from that reference point that I created. So that's what the control do when you are picking. So instead of becoming the pick point, it becomes the reference point. Then, so we have now the wall panel here. I will now create the remaining panels using the panel properties, which is this one. So again, I will press the Shift key and click the icon. So I want a 3.6 meter high and a 175 panel here, which is good. And I will use the reference of the last panel here. So I will click the control again and click. And then I will snap into the line and type in 20, which will be the gap of my panel. And then I will continue tracing the drawing. So I will try to find the end of this reference model or reference drawing. And then from here, I will right click again, perpendicular. And then I will try to snap into this corner here. Then I will right click again and press end. And I will try to look for this end point here, which should be the same as the 29. That shouldn't be 2930. Let me just press the backspace. The perpendicular again. Yeah, 2912.5. Then press the end. We should have the same. So just be careful on the snapping since we are working on the 3D. 2930.30. Are we having a different snap in here? Two nine 12.5. We should have 2912.5 in here. And then as I go into this intersection, I will press or hold the control button again and click and go back by 10 mil and press the middle point. And we will have this panel in here. And to finish up, I will create another panel. So press the control again, click in here, snap, and type in 20. And look for the final corner. So it will be easier to trace this reference drawing if we change the color. So if you find it a little confusing, you can change the color of the reference drawing. Now I will change, or I will add the radius here as well. Rounding, and it is 2912.5. We have our panel here. Next, I will lower this adjacent panel. I will snap into here. So while using the direct modification, or turn the direct modification on, and I will add another panel on top of this panel by using the panel properties. So again, I will click in here, and I will hold the control again and click in this point, and then type in 20, press enter, and on another end, I will click the control again, click, and type in 20 again, and press the middle button, and I have a panel which have the 20 mil gap now in here. And then using again the direct modification, I will snap on the face of the top, and I will just snap anywhere in here, and they are now on the same level. So next is I will try to add opening in this wall element. So using this add rectangle opening. So let's say 1.5 from the edge, and then we want a 2.1 or a 1.2 by 2.1 opening. There we go. That should be it. Next is split this panel here. So we want this to be a sloping, to add sloping on the top. But let us split it first. Now, what I will do is I will press the Control P. And then I will create a section view from here. To make sure that your section view is perpendicular, it's better to snap on the grid lines. And I will try, or I will change the depth to 200. I will also press Control P in here. What I will do is using the points, I will add 4 divided points from here. Before I do that, let me first move up all the panels to put some gap, like 20 mil gap from our footing. I will add 20 and move all of them at the same time. This should be easier to do before you create the connections and all other fitments. Then again, let's add the points. Click from here to here. So we can see the points in the 3D. And when we click the panel element again, we use the modify seams. So we need 20 mil gap, and just click on the points that created. Okay, we have duplicating here. So to create the slope, which one is the duplicate? Anyway, we will be exploding this later on. Okay, so again, before adding connections, if we have nothing to do with the geometry of the panel, we can now explode. We can now explode those panel elements. explode this one. I will explode this one. I will correct first here. This shouldn't happen, but for some reason happened, and we have to correct it. Okay, so let's set this view aside for the meantime, and let's go back to the 3D view. Before doing connections again, another thing is to check the panel form face. This determines the the front face of the and the table face of the panel, and it needs to be corrected before creating the connections and the drawing. This is why it is ideal to model the panels from left to right. If I turn off the direct modification, you can see the yellow and pink, which determines the first peak and the second peak. So we want to pick the panel left to right as much as possible. Now I will select all the members, and from class unit, show top inform face. The red hat shows the front view of the precast panel, and sometimes we call it the trowel face. And the other side is the table face, which is a lot smoother and most of the time placed on the external face of the building. So I guess we are now ready to put on the connections. At this point, I will use the detailing manager here. So I will right click and properties. So I have a preset here, which contains lifting, propping, grout tube, and all other stuff. So I will apply. I will not use these options for now. So I will just apply an OK and use it from the icon. And upon clicking each panels, you can see we now have all the elements like lifters, propping, trimmer bars, mesh, and grout tubes placed all together by using the detailing manager. So we will also add the casting plate connections from side to side of the panel. This connection is available in the Tekla warehouse under the building point concrete collections. I will right click properties. I will load the pre-save, which contains two casting plate and fish plate. Click one panel and the other. Okay, so we have now the casting plates connection side by side. I will also add corner brackets for this side. Let us apply this first. This panel. And this one. Go to properties. Let's load the one for the bottom. And another one for the top. Next, I will add a vertical connection for this panel and for these two panels. So I accidentally drag the face, click in here. And let's say I want to have grout tubes with max centers of 800. And we want to add a lap joint for stormproofing. Want to have returns on both ends. We have this shiplap connection here. And if we want to add some propping on these panels. Okay, so if we don't have any slab on this level, so we want the bottom of this propping to the bottom of or to the top of slab. So we can measure, and what I do when measuring in 3D is I make sure that the model origin or the UCS is in the model origin, and then I use the move linear and pick the 2 points that will determine the distance of what I want to achieve, and then I check that value. So I'm looking for the Z value in this equation. Simplify, and we have our wrapping like this. And last, I will add some reinforcement. So this reinforcement that we are using is using the rebar group and mesh properties, which is not as intelligent as the rebar sets. So you can see some clashing or clashes with each other. So finally, I will create a panel rebate at the bottom for the slab connection. So I will use the other section in here. By loading the panel properties, I will load the preset here. So we need 100, or we have 100 thick slab. So what I will do is I will click the panel and I will press the control button, control key again. Click here and go up by 100. From there, perpendicular, click again, perpendicular, click again, perpendicular. And you will notice that uh, why I keep on adding the panel rebate individually instead of copying it. So in this situation, the panel heights are different. And if we do copy the panel rebates, what will happen is, so this is my source, this is my destination. It will put the panel rebate in a different elevation, which we will end up moving the panel or the slab rebate later on. So still better to put in a slab rebate individually in this situation. So it's like a case-to-case basis. Okay, now that we have the connections and the reinforcement we need, we can create the drawing or the cast unit drawing. But before we do so, let me show you one important feature that most of the time forgotten when detailing precast panels. It's whether the fitments or the casting items are correctly set to be near face or far face, table face, or in the table face of the panel. So for us to check this, you can go to the properties, change the representation to near side, far side check, modify, and you can see that all near face here are showed in green. So if we change this near side to far side or near far face, they will show us red. The same goes with the wrapping. Change this to far side, they will turn red. If we put them back in, they will turn green if they are near side. Okay, so let us now create one drawing. So number create and the drawing. Okay, so if it's a bit congested, we can change the layout size from A3, let's say, to A2. That looks a lot better. Then, if you want to show the missing rebar schedule and mesh schedule in here, you can just double click, go to the user defined attributes, and show the Rio mesh table. Set it to yes, modify, select any template, right click and refresh, and you'll have the mesh schedule. And if it's too small or too big, and you don't want to mess with the standard layout, just select the layout, right click, and exclude from template. And from here, you can now modify it using the drawing layout editor. Change the scale, say 1.5. Close and save. And you have your table with different scale, which is included, so we are not messing up with the drawing layout. We'll close this drawing from now. And okay, so for more reinforcement options, so I showed you the traditional way. I will give the floor back to Jeremy to show you the rebar sets and how to apply it on the curve panels. So I will write out now, Jeremy.
Yeah, mate, good stuff.
And
I'll just do a quick read in.
Just on that, Jeremy, maybe you can show what kind of information it produces when you read in.
Do you want me to just share my screen then?
Yeah.
So it's reading in all of Oscar's panels and data that he's put in there, propping included.
and even the drawings.
So there you can see what's been added. It changes the color of things that have been added, so you can see it quite clearly. And it also gives you this list here of everything that's been either modified or added. So if it's been modified, it comes up yellow. If it's been added, if it's a new item, it comes in green. So you can scroll right through that list, and there's quite a lot Oscar's put in there, from rebars to ferrules to washers for the propping. Everything's in there. So including drawings. So there's the drawing that he created, and any files in the folder that have been updated as well. So it's quite comprehensive, the amount of information that you can get just from a shared model. Right, so now the reason Oscar's reinforcing isn't showing is because I've got it turned on to fast for the reinforcing, which I'll leave it like that at the moment because it just makes the model run just a little bit faster. Now we're going to use some rebar sets to reinforce these last few panels. Now there's a number of ways you can do this. With the straight panels, you can actually use by face. Where's my properties gone? There they are. So by face, you can just select what bars you want. So I tend to try and work from the outside of the panel inwards. So you put the outside bars on first. So generally with precast panels, the outside bars are your horizontal bars. So we'll go 12 mil N12 horizontals. We'll make them red. And yeah, 200 center sounds pretty good. There's a number of different ways you can set your bars out. You can have equal distribution by number of bars, or you can have a target spacing. You can set your exact spacings if you want, which is a comma separated thing. So you can put your spacings in separated by commas if you want them to a specific spacing. But we'll just go equal by target spacing value. So, and we've got it set at 200. So when you hover over your panel, It gives you the horizontal, or depending on where you move your cursor, it gives you vertical. So we want horizontal there. So we're just going to put those in like that. Before I get too carried away, again, we need to set our cover. So let's say 50 top, 50 bottom. Front, we're going to go 30. Back, we're going to go 30, and then we're going to go 50 again. And modify that, and the bars just move slightly then. So what we'll do is we'll do the same on the other face. We'll go by face. It remembers your last bars that you selected. So horizontal, click to select those, and now you've got your horizontal bars in there. So now we're going to want to throw some vertical bars in. Now we'll use crossing for this one just to show you how that works. Hopefully we can fit 16 verticals in here. Make them green, and we'll close them up to 150 centers. So if we hover over that, we get that. What we're going to do is we're going to remove crossing. We're going to remove the bottom bar because we don't need the bottom bar there. No, okay, so 16 is too big to get cover because I've set those covers. So let's just undo that, and we're going to go back to 12s. Again, it'll go red if you do something that doesn't fit within the cover. It won't produce the bars correctly. So we're going to change those back to 12s and do the same thing. And they're at 150. It's probably because it's two layers. What I might do is I might just change that cover to...
Could it be the top bar bend?
No, there it is, just a cover on the sides.
Right.
Because what it does is it adheres to that cover really strictly. So so there we go. We've now got the vertical bars in, which have got a hoop at the top. What we want to do is probably put some returns at the bottom. So if we make sure your direct modifications on, you can select that. Then we go in detail. Now, this remembers the settings from when I did the foundation. So if I go back to standard, then it sets them all back to standard settings again. So we can start again. So we're going to put in some 180-degree hooks. Now what I'm going to do, I'm going to put that hook in there. And if I select that again, I can select that modifier and I can go copy and copy it from there to there. So now we've got hooks on both sides. What happened to that? Oh yeah. I'm not sure why that bar's got a rotation on it. Oh, it's rotated it because it's a U bar. Okay, so I was going to say what I would quite often do is I would actually put a hook rotation on this of 10 degrees, just to avoid clashes. But it's already done that. So the bar sets are very, very intelligent. So there you go. There's a 10-degree twist on the bottom, and then you would do your top bar, do your returns on your other side, on your sides, 90-degree in detail, 90 degrees. Now you can see it's returning them the wrong way. So I'm going to put a 90-degree bar rotation on that. And then you can do exactly the same as I did before. We can grab that bar and we can take the modifier, select your modifier and copy it from there to there. And you'll see they've come the other way. So what we do is we grab that modifier there, and you can either put in 180 or you can go minus 90. Works both ways. Now, as you can see, the bottom bars there are sticking out through the panel. One thing I normally do when I'm doing panels, I'll put these other returns in, and I'll show you. So remembers your last settings. Copy that modifier from there to there, and then select that modifier and take the minus off. Right, and because you've got end bars that are sticking through, which will quite often happen, what I like to do is if I grab that, there's an option down here where you can exclude the first and the last bar. All right, so it removes the first and the last, and then I'll do the same with the horizontal bars. First and last, remove it, and remove the first and last bars. So then we're left with a gap, and then we'll use one of the other tools in the applications and components here, which is under walls, and this is the one I like here. We're just going to leave it pretty factory. So this is just a trim bar tool, which will set your trimmers up, and you can set your corners up however you like them. You can put a corner bar in if you like it done that way, or a single return on one of them. We'll just leave it by default. You can decide whether you want crossbars on the corners to stop the cracking, and you can set any cutout sizes. We might make those 10s. And you can set all your covers and your laps and everything in this tool. You can also add horizontal bars and vertical U-bars, which you can use stirrups and stuff for if you need to put stirrups in. And then we're just going to OK that. So then that generates some nice tidy trim bars around the outside. Now these bars are bar groups, not bar sets. So they haven't got quite as much intelligence in them, but they will still adhere to your cover. So so that's your straight one. Now for doing a curved panel, we're going to do the same as what we did with the foundation basically. So if we go into rebar here and we grab the crossing bars, what are we going to use? We might go 10 horizontals, and we'll change those to green, and then you hover over the side of your panel, and we're just going to put those in as a whole U-bar basically, which you're not gonna do, but I'll show you how to split them in a minute. And then we'll do the same with the vertical bars. So we'll go in and select a different bar. Actually, I'll select, yeah, it is crossing. Let's go 12 mil verticals, and we'll make those red. And we're going to do the same as what we did last time. We're going to put that one in there like that, and we're going to get rid of that bottom piece. Now, go back to the plan view, and you can see those bars are quite twisted there. So again, we need to grab that handle and put it to the end of your panel, but we want to have it either at the top or the bottom. It doesn't matter which, as long as it's one or the other. So let's go top and drag that one there around and go top. Just check that it's on the corner. Perfect. So back to plan. Select those bars again and use that same command there. It doesn't like it this time. I might not be quite on that point. That looks pretty good. There's the problem. So it has to be right on the corners for it to conform and stick with that line. So you can see now that it's all the bars are nice and square off the curve of the panel. Right, so what we can do now is we can use some of these bar modifiers. So if you select the bars, I'll close that one up and get it out of the way. Select the bars and you get your rebar set tools up here. We're going to add a splitter. Now, by default, it's already set up as a standard to split, but you can have standard lapping or you can customize it. With the small bars, you don't need a crank, but if you want to put a crank in it, you can. Or with bigger bars, you can put a crank in it. And then when you hover over it, we'll get a wee bit closer. Well, we might just put it at an arbitrary dimension because I'd have to create a new view and snap and have it sitting square. You can then basically select wherever you want it. Let's just put it there. And you can see straight away that it's split those bars and lapped them. So then if we grab that, we'll just do the same on the other side. I'm sure you can probably copy that over, but for the sake of this, there you go, put them in the same spot. There's a number of things you can do with these laps. You can obviously adjust the size of them. So if you select that straight orange line, that gives you adjustment in your lapping. So you can change it whether it laps in the middle, whether it laps to the left. So if we go lap right, you'll see those laps have moved to the right of that orange line now. Oops, where are we? Over here. So those laps have gone to the right. If you go left, it'll lap to the left or the middle. So you can tweak those. If you've got a whole lot of laps in one line, I know engineers don't like that. What you can do is, I'll just jump around the inside and do this one because it might be a little bit clearer to see. So we can grab that modification line there, and you can have whether they're parallel or on top of each other as well. So on top of each other means that if you're looking at them square, you don't see the lap, or parallel, and then you can add a stagger to them. So you put your stagger offset. So you wanted a meter stagger, then it staggers the laps so they're not all in the same place. So you got one over here and you got one over here. Now that, I know engineers will like that because it just means that they're not all a weak spot effectively in your panel. But we'll take that out for now. No stagger. And yeah, they're back to normal. And you can actually do the same. I haven't quite got it set up, but you can actually do the same with couplers. You can throw couplers in there the same way. So that then gives you U-bars on the end, and then curve bars on the outside. So what we'll do is we'll throw another splitter in this side, just so we can then produce a bit of a bar schedule for you.
Yeah, maybe Jim, maybe jump to the bar schedule straight away because I just mindful of the time. Yeah, we'll jump. Okay. Yeah, we'll just jump on a again with the Q. Yeah, with the while you're doing this, with the Q&A, start writing your questions up if you want to, or if just put in a comment that you want to get back to, maybe have another demonstration from us as well. We can do that at a specified time or agreed upon.
Right, so for when I do bar schedules, what I do is I hold the Alt button and select the panel, and that selects all the bars inside the panel as well. So I generally do it per panel, and then we go into reports, and there's some really good reports in here, but I like the PDF ones. Rebar schedule and create from selected. Oh, I've got to do numbering first. Sorry, guys. All right, it's modified. I'm going to assign those numbers. I'm not even going to look at them. And we're going to go back to our rebar schedule, create from selected. Right, so that's the rebar schedule that we got from the first one. And it gives us a breakdown. It gives us a cut length, the bar shape, the return sizes, everything. And you can tweak that and adjust that as well. We'll do it for the curve one so you can see the curve one. Wrong button, Alt. And then reports and rebar schedule. And there you can see there you've got your curved bars there, you've got your hoop bars, and the ones where we put the splitter in them. So it's very quick and easy to produce those rebar schedules. You can also output as BVBS, which is a very small text file that most of the bar bending machines can read. So when you import that into the software that runs your bar bending machine, it produces the same sort of bar schedule as what we just produced. So they can then look at that and compare them. And if they're happy that they're correct, then they can just push the button. And I think that's probably all I need to show you for now. I'll pass you back to Andreas.
Thanks, Jeremy. While you're still there, can you do a baseline as well? Go in, not right out, but just a baseline. If you go to the menu, yep, then model sharing.
Oh, for the Trimble Connect.
Just sharing, yeah. And then create a baseline. Yeah. So what is, because we mentioned the sharing aspect of it as well. You can set up Tekla Structures to, with each baseline, it basically creates automatically an IFC model, and it will send it off to the Trimble Connect project that is linked to this specific specific project. So while he's writing out, I'll just prepare my screen.
I was going to say, you can take the screen now if you like, mate.
Yeah, just one sec. Minimize. Start sharing. Your probably settings are not set as per that, but doesn't matter. Yeah, so with each, you can set it up with each baseline. If you still have time to stick around, there is this collaboration platform called Trimble Connect, which basically is a continuation. Let's say after the Tekla Structures model, you can jump in and put in any of your files and folders and models in here, and what it does is you can set it up automatically to export and put it in an IFC model in here that you can later on have a view, edit, and basically review it, put some more elements in here as well. So for now, we don't have anything else. If we would have other models, you can just place them in. If you have a point cloud, you can place here in as well. If I need to change the transparency and check where those bars are coming from and so forth, if I need to have some basic measurings in here as well, I can put in those to double check if it's actually 20 mil. What's the spacing between these two? If I need to get information, what kind of bolt is that? I can quickly go and check in here. This is an M12. I just mark it as my favorite. So if I click on any of those bolts, I'll see it at the top here. I can grab any information that Jeremy specified in his export settings. So you can see here like the height, weight, areas, and so forth. And from here, I can even, if I go back to this area, you can go to the team's environment and then invite members so that they can view it there as well. But another option would be if you just want to share it with someone, that model that you've just done, you can go in and just send it to anyone with a link as well. You specify people basically as your own, as yourself, and then when you get the link, you can set it up when does it expire, do they have access to view only or just view and download, and if to show the latest version as well. So if it's ongoing project, you wanted to click on the show latest version, so every time you update, they're using the same link, always have the newest information in there. Yeah, so that's one of the ways that you can share without using, let's say, emails and so forth.